automatically society will correct. You cannot expect the society to correct individuals. Individuals only should correct.
No.
That's why we don't have punishment, okay? If you have in my class 4 absent, F. You put it in the syllabus, tell it in the first day.
Okay, I think who else is left? Who? Prashant is not there. Prashant sent. Huh? No, he is not volunteer. He is a.
Anyway, you are whether volunteer or not. I tell you class now. What's your name again? When I came, no one was in the room. You were in second center. What time you came?
9:28.
Here we only support.
Okay, I think we are going to start. We're not going to hang on because see, there are most important thing why I am insistent time is this is a central facility which is to be being used. So it's not for us all the time. There is a certain booking time when we have to use it. We cannot be. So I have to do it. Gyanendra has not. Gyaneshwar has not come.
We have to wait for him.
Gyanendra is enthusiastic also. So
On the way. Maybe we should arrange a vehicle and drag them on time.
yeah, I can arrange a vehicle. That's not an issue. The point is they will not get a chance to explore the campus if I arrange a vehicle.
That's okay, but the purpose of this course is not to explore the campus.
Yeah, so he is here. Start. So we come back today. What we are going to do is we have so far looked at so let's say developing certain measuring instruments which will give a kind of a index of your health. Then we have seen what is called as a therapy using electrical techniques, so which involves now in this what has emerged is you have small currents, high voltages or high electric fields involved, and therefore today we will try to see how we can compute those fields because it's going to be electrostatic phenomena which is going to be responsible for application of these things. It could be continuous, that is DC or AC, or it could be pulse which is transient. So you may work on say static fields and other are what are called quasi-static fields and time varying fields. So we look at this, and what we look at is we look at from a simple perspective, then we talk about the field distributions to get the stresses, and therefore when you do take a complex geometry it may not be amenable for simple formulae. So you see that you come with simple polynomial equations, then differential equations, partial differential equations. So you are forced to use some kind of a numerical techniques. The electric field problems are categorized as two, open boundary and closed boundary. So you use either differential equation approach or integral equation approach, and the common techniques that are involved are finite element, finite difference, charge simulation. Charge simulation is the integral equation. Any method you think of can be categorized into these two, that is integral equation and differential equation, or open boundary and closed boundary. So there application of a package involves, and what do? You have conducting materials, dielectric materials, static when you say electrostatic phenomena. If you talk of electromagnetic, you will also have magnetic materials coming into picture, and therefore you end up having these space and time dependent differential equations which become partial. You do a numerical solution, so you may have to use some kind of a numerical analysis tool, and today afternoon we'll spend time on that. I have already sent, Naveen, I have not sent it to you, but I have sent it to others, the executable for ElectNet. We have a video also which we will see when the lab begins, okay. And right now you find that any of these packages has three things. First is defining the geometry. When you say finite element or finite difference, the two techniques, you divide the geometry into various regions. So how you and in the region you define the material properties. Now imagine in a insulator you talk of conducting electrodes and insulator. Here what do you talk about? Organs or tissues along with the electrodes through which you apply the electrical voltage, maybe pulse or maybe non-pulse nature depending on the type of application and goal you have in mind. And therefore, you will look at discretizing, which is often called as pre-processing or meshing in the finite element. See, many of the packages which you have, they may be using finite element, finite difference, charge simulation, boundary element, any of these methods depending on the need. Okay. So, everything is not finite element, that is number 1. Number 2, after pre-processing, governing equations are solved using numerical techniques, then you have a post-processing. Display is a very important thing, and you know engineer's tool is basically a picture. A picture is worth 1000 words, therefore, you finally display the parameters which you observe and look at them, and in fact today you have very good graphic supports which will give you the display. Now oftentimes people call all this a simulation, but I have a different view. That is because of I was introduced to simulation by one Professor Sharma of IISc Bangalore, who defined, he is a computer science professor, he defined simulation only when you include the statistical nature of the parameters that are involved, it fits to be called as a simulation. Otherwise, it is essentially a numerical computation, and that is why we have called this field computations. So, from the physical standpoint of view, Professor Rajesh Sundarajan will talk about how these things are applied to biological systems. I will recap some basics and then we will run through a video on ElectNet, which is to be used in the afternoon, and then we can solve some problems concerning various on using ElectNet in the afternoon. This is the plan for today. So, I think we could not take up gene therapy yesterday. We will start with gene therapy. Yeah, your quiz has been graded. She would like to tell you about your performance vis-a-vis what was expected. Idea is at the end of the thing you should go back with what is expected.
Thank you. Hears me okay all these days? No problem, no? So, a very good morning to all of you. Yeah, because you know I always enjoy grading the quiz because that reflects me how well I taught, okay, rather than how well you did. So, here it is, highest is 97, okay, and there is a 95, there is a 90, and then below that. You are Antare? Massa, that's it. You are Kendra Kumar, congratulations. Dr. Giridhar, congratulations. Dr. Hussain, no? Prasant Sen, who is not here. Then Rushpa, she is not here. Rupsha. Subir, he is not here. Sandeep, he is not here. Okay, so those of you who have, in general I think I was very liberally grading the first pages, okay, and sometimes some of you didn't write on the right values of the biopotentials, okay. So I normally give, and even I at Kharagpur does, make a quiz, okay. So in the end those who got below 90, you don't want to, if you got 90 and above, 90 is A for me, you are out, okay. I don't want to keep grading, okay. So only those are, but if you want to take, because I am supposed to give equal opportunity to all, so if you want to take, you got 97, you want to retake, be my guest, but when you retake it won't be more than 90, I cannot give, okay, because it is a retake, maximum is 90. Understand? So, those of you who were absent, you can take it. Okay? And then I want to go over it again. I want to make sure all of you are thorough with the electrochemotherapy. So, let us discuss. We will talk about homework later. Let everyone come. Okay? So, tell me what is ECT, because I want you to be thorough, then only we can proceed further. What is ECT? Because tomorrow is quiz, correct? So, I want to be thorough. What is ECT? Where are the files?
Chemotherapy in a specific way using a electrical pulse.
Okay, you have to be very, very. Sir, where are the files?
You want the files, 1 minute. You want chemotherapy file?
Yeah. I think I wrote it down. It was in one of my slides. I want everything to be accurate. Okay, engineers, we don't know. We are not English literature, wasting words. Okay, electrochemotherapy is electrical pulses plus low dose chemo drug. That's it. I want. Okay, tomorrow when I explain electrochemotherapy, I only want to see words. I don't want sentences, which makes no sense because I don't get what I want in your sentences. Okay, electrochemotherapy is electrical pulses plus low dose chemo drug. Make sense? What is electrogene therapy? Electrical pulses plus gene molecules. Electrocurcumin therapy, electrical pulses plus curcumin molecules, like that. Okay. So, we have electrochemotherapy, electrogene therapy, electrocurcumin therapy, electrocalcium therapy. We can use calcium molecules to treat cancer. Electrovaccine therapy, electro miRNA therapy, electro chemotherapy, because radiation and surgery couldn't help all the patient. Okay, this is current standard of cure. Current, okay, forget about all other things. They are all minimal. Hardly 2% people use it, so I won't even consider that. So, when the current standard of therapy, including surgery, radiation, and chemo, I want that order. Any other order, big zero, is not working for patients. Okay, for whatever reason, including advanced recurring tumor. Remember I told that sarcoma case, the thigh case, they treated him 3 operations, still it comes. The doctor gave up, how much you can cut, you had to cut the bone. Okay. So, when the current standard of cure does not work, okay, for inoperable radiation resistant, chemo resistant tumors, we need an alternative, affordable, safe, effective, economical, physical technique. Why we do not want chemical?
It has side effects.
Physical means it does not, okay, electricity does not have boundaries, it does not care whether it is lung or kidney. If you have to give chemical drug, you have to give lung is different, kidney is different. Electrical pulse have no boundaries, it does not have any distinguishing property. Some people can call it as a negative, we will use it as a positive. Make sense? Okay, that is why it is. And then how it is done, how we want to talk about the mechanism. What is the mechanism? What is the mechanism of ECT?
We concentrate drug where it is to be used and
what is the mechanism? That is procedure. What is the mechanism? Exactly. Okay, remember yesterday I wrote there, application of electrical pulse. Electrical, okay, the cell membrane does not conduct, it acts like a capacitor. Okay, you are all electrical, something related to electrical, correct? Even mechanical they learn electrical. Application of electrical pulse, accumulation of charge, development of voltage, everything you have to be in that order. Okay, when the voltage there is a gradient, correct? The voltage is across the cell membrane, which is got a ring type of thing. So, the width of the cell membrane, which is in nanometers. Okay. So, voltage across the gap, the cell membrane thickness is electric field, correct? So, electric field is what? Remember, work done is force times distance. So, force is work done divided by distance. Same here, voltage divided by distance. So, electric field is a force exerted by unit charge either on itself or nearby. Okay, electric field is a force, and then the voltage is the, what is voltage? Yesterday we talked about it. So, work done, energy, energy. Okay, so we can do P equal to VI or we can do W equal to Fm, W equal to Em, okay, all that comes into picture, okay. So, force, okay, so when the electric field exceeds the normal withstanding capacity, it breaks down like a lightning. Everybody remembers lightning, you know how it happens, okay. So, it opens up pores, allows the molecules to enter which are not normally allowed, okay. The cell membrane will not allow, Mother Nature made it, otherwise every Tom, Dick and Harry will go inside and you will get infected and die, you understand. So, it is protecting us. So, it is important to open up the pores, okay, externally agent, okay, it normally does not go, we allow it. So, it goes in, and because all the molecules drug concentrate in a limited, localized, targeted area, the effect is dramatic. You remember, you take a pill or a IV, the whole body it goes, okay. To the cancer portion only 2 or 10% goes, whereas if you use targeted, localized, it goes everywhere, you understand. So, tomorrow everything I will ask you to use exactly what the terms I used, okay. Then how it is happening, okay, how are we doing in the clinic, how do we do, now you come.
We have an electrode,
Okay.
through which we apply the pulses.
Okay, so before that what do we do? What is the procedure?
Swapping.
Local sedation, okay, light sedation, you give the whole body light sedation. So, you are not into coma or anything, okay. Light sedation, local anesthesia, you want to inject there. So, you want to keep that place to be immune to pain, okay. Light sedation, local anesthesia, injection of the chemo drug, you have to inject the drug molecule first, why? Why not apply the pulse and then give the drug? Because
The drug may get modified.
when you apply the pulse, it opens, you want the drug to be readily available to go into it, okay. Because by the time you inject the drug, the pore can reseal, because we only apply 100 microseconds.
Yeah, I'll add a point here. Drug is flowing, say fluid motion is slower compared to the pulse application. Say pulse is a very short duration thing. If you don't have the fluid already available there, as she says, before the drug can go in, pore may close.
Okay, and what are the pulse parameters? What are the values that decide the efficacy, the effectiveness of the electroporation?
1200 volt.
Pulse parameters, I am done as the values. What are the parameters that decide?
Frequency, magnitude.
Again I want the order. Which one will be most magnitude, intensity of voltage applied or electric field, okay, very good. Second, duration of the pulse, then number of pulses. Last comes, okay, because we studied all this, so we know which one is dominant, okay. We did electrostatic, what's that, statistical analysis, everything. So, the voltage or field applied, pulse width, number of pulses, then comes the interval between the pulses, and you know the values, okay. So, I would not ask that, I will see that tomorrow, okay. And then what is the advantages of ECT? I think I showed in that video. Pain reduction, main, pain control, pain relief, some cases, okay. These three are different value, different in different things, you know that, right? Pain reduction is different from pain control, is different from pain relief, 3 things. Organ saving, I do not know how many of you remember organ saving, I told you an instance. Who remembers that? Okay, for example, take tongue, okay. Normally if you get tongue cancer, they cut the tongue. In electrochemotherapy, 90% of the tongue was saved, protected, only 10% flap reconstruction, okay. What is flap reconstruction is? Take a skin, flesh from somewhere else and do that, okay. So, these are all very important, correct, if you remember, especially tongue cancer. And I saw a patient whose tongue was cut and how he spoke in Tiruchi, and here we treated 2 patients and no one's tongue was cut. And okay, so that's I want you to really appreciate so that you will be our ambassadors to carry this everywhere. And it's also very economical, okay, very cost effective. You can do it outpatient based, it is safe, it is effective. I don't think you can ask for anything else, less or no side effects, okay. That pain for 24 hours and all, I don't call it side effect, you cut the surgery, how much pain you have, how much cost it is. This is nothing. Chemotherapy, God, you should take, then only you will know what it is, okay. So, always read, okay. So, do you understand the importance, significance, the relevance of this technique, okay. Less time, yeah, very simple. Yeah, it takes few minutes, okay, per nodule, okay, because if you have a 10 centimeter nodule, you have to apply, takes, what, 8 seconds per each one, okay. So, it is only the human time.
Yeah, look at it another way, you are injecting less drug, okay, that also means
low dosage,
localized.
1/10 or
So,
lower
all
than.
this basically makes it faster and as an outpatient thing itself for all practical purposes.
Correct, you do not need costly
See, in
facilities.
fact, today's healthcare, we discourage people being admitted in the hospital because you can catch secondary infections.
Yeah, or you will transmit infection to someone.
Even doctors take antibiotics every now and then. You know why? That's called prophylactic treatment. They have to do it because they're dealing with infections all the time.
Washing hand is a very good thing even for us and for them. Many doctors, nurses don't even care that. Okay, that's another thing. Okay, and the ECT applications, for which cancer we apply this? Virtually all solid cancers. Okay, where? Okay, so you can tell breast cancer, tongue cancer. Okay, and then what else? This one, head and neck cancer, melanoma. Okay, and then. Yeah, head and neck covers many, esophagus, everything. And then even some people date, it is called ex vivo. Who knows what is ex vivo means? Okay, you take the lung, remember with some people.
Organ is brought out in a test tube basically. Vivo is tube as a container.
Vivo is kind of live. Vitro is glass, that is a cell. Okay, ex vivo is outside the body. Okay, so for example, some people asked, what about blood cancer? Can we treat using ECT? Yes, it is theoretically possible. Take the blood out, pulse it, put it back. Okay, G is doing for platelet. Remember if you have diabetes and other diseases, your platelet count will go. They take it out, pulse it, because the current therapy involves costly and takes long. So they are studying this. There is even paper published. Okay, we even submitted a proposal to your SCRB, collaboration between Purdue and IIT Madras. So to treat, this will reduce amputations. Okay, per day 200,000 people in the world are getting amputated because of diabetes. Okay, so we can reduce all that using electroporation. Okay, so we can do many things using electroporation. Do you get a good idea? Questions? It's okay to yes.
What about the tumors which are not visible from outside? How to
That is when your chemotherapy comes. Remember?
can't use ECT on the
If it is not visible, where will we put the electrode? Okay, yeah, that's why. See, I have a lot to share. I don't know whether we have time. I will show you something. When we talk about that, remember I told pancreas. It's very difficult to know where the tumors are. So they use ultrasound based imaging, and based on that image, they will guide it, and then they'll go and hit it. Someone asked, what about heartbeat? Yes, they correlate heartbeat with the application of pulses. Okay, I feel it is not needed, but remember the person is in what you call long coma or something. They will be like in what's that temporary coma. Okay, you have to immobilize the whole body. So maybe they want to correlate or monitor the heart rate and the application of earth. Okay, so it's all there with the Dr. Robert Martin's slides. Okay, so we will see that. And then I will quickly, because I only got half an hour, it's already half an hour I guess.
It's okay, you take till the break.
Okay. Okay. Is that okay with you? There will be some slight changes, so we will make it up somehow. Okay, because no, when we discuss things, you cannot just stick to the timeline. I think you know that from. Okay. I think we will skip all this, we did all this. Okay, ECT, you have all this, ECT application advantages, okay. So tomorrow I expect a very good performance.
Assignment yesterday?
Yeah, I gave assignment 2 and 3 already. And wait. Did everyone do a good job? Because I don't want some haphazard sloppy assignment. So if you want, take today also, turn in homework 2 and 3 tomorrow. Did everyone do a good job? Is there a sketch there? Okay. Otherwise, if you need more time, let me know, because the purpose is learning, not turning in on time. Do you understand? That is also important, but this is more important. So if you need more time, turn in both tomorrow. The lab report and the assignment too, both tomorrow due. You can pass it to those who are absent. And no more extension, that is good enough, because we have assignment number 4 for the next day. Okay. I think we saw all this. Okay, I will go to IRE first, okay, and then we will do the gene therapy. We saw all this, correct? Okay, remember we will be using drug and electrical pulses for electrochemotherapy. Drug is poison, drug has side effect, drug has drug resistance, drug has allergic reactions. So won't it be nice if you have a therapy where there is no drug? Yes or no? Okay. Enthusiastically react, okay. So this is okay. One such technique is called the irreversible electroporation. You guys were always asking, now what happened if you increase the field? Here what? If you increase the field, you will scale the cells. Okay, so why not we do this all the time? Why we have to use electrochemotherapy? Why not we just use electrical pulses only? Okay, remember, one size does not fit all. Okay, like how we cannot erase surgery, we cannot only use ECT for all, because in the case of ECT we have the the influence or effect of the drug. Okay, though it is poison, it has some benefit. Okay, it can kill the cells. Okay, which we enhance using the electrical pulses, opening of the pores and all those things. Also, when we apply the pulse, even though it is 1 or 2 degrees centigrade, there is some heat generated. So the combination of electrical pulses plus chemo drug plus heat, what do you think? You know the word synergy, correct? 1 plus 1 is, what is 1 plus 1 when there is synergy? More than 2, it is not 2, it is anything more than 2, it can be 3, it can be 30, it can be 3000. Okay, synergy comes into picture, because each one will react with each other and they will enhance the killing. Okay, here our goal is killing. So yes, yesterday someone asked, then why not we just use it? We will use this, we will use that, we will use whichever is possible, whichever is effective. Okay. So there is no drag, just electrical pulses. Again I will tell the parameters right now, note it down. I think I wrote down yesterday, 1500 volts per centimeter, 100 microsecond. Okay, some publication give 99, but we can call 100 microsecond, 90 to 220 pulses in trains of 10 pulses. You do not apply all that in one. Okay, you apply 10 pulses, give a gap, apply 10 pulses, give a gap. Okay. Normally I was speaking with Dr. Robert Martin, he is in Louisville, he is a surgeon, he is doing pancreatic and prostate, liver, everything using electrical pulses. He says he will apply 20 pulses, see the current is high, then only he will proceed, that means it is effective. Okay, because remember, when you have the tumor, if it is fleshy, it will have lot of blood and everything, conductivity will be very high, resistance will be low, so you need to get some decent current. If you do not get current, that means you are not hitting the right spot, so he has to go back and check his the ultrasound, the imaging guide again, and then they have to go. Make sense what I am talking? Okay. So okay, and then he will apply, typically they go for 90 pulses, and then depends upon, okay, so the tumor is big or the tumor is like solid, they will go. Okay, remember, this is another thing, how do we distinguish between normal and tumor things? Okay, there will be flexible, and then normal this skin is flexible means the tumor skin will be thick, but when you have the tumor that will be flexible with a lot of blood vessels and everything, because the cancer has to survive, so it will do everything buy, borrow, beg and steal, it will take everyone else's energy, that is why it will have a lot of glucose content, the cancer cells, because they want to survive at any cost, at the cost of killing the very body in which they are, because they do not know that one, so they will do that, so we can use electrical pulses for certain applications, and you know the parameters. So considering that all the side effects and the difficulty in drug delivery, the drug has to go through different route, the stomach ulcer, what is the stomach gas, whatever in the stomach can react with it, So a drugless or a drug free treatment is ideal for any cancer, and pancreatic cancer is an ideal candidate because it is the deadliest cancer of all, and we do not have a good therapy for that, especially advanced one, So especially when the current standard of treatment including surgery, radiation, radiation should come second, and chemo do not work, They use for something a device called nanoknife which will inject the pulses, It is neither a nano pulse nor a knife, It is just an electrical pulse generator, but they call it nanoknife just to get the attention, Here are the pulse duration. Sir, I need the
point.
Also, can you switch it up? It's cold here. This fellow, that fellow.
This fellow comes here.
Oh, okay, whatever. This is Dr. Boris Rubinsky. He is still in UC Berkeley. I think you all know UC Berkeley is one of the top schools in the whole world, He is from Israel. He was the one who made it happen. First he started the clinical trial in Israel, then it was followed in Australia. They treated 20 patients each in both cases, and they all get benefited, Since then now it is spreading all over, So this is that, the probe they use in the nanoknife. And here I
call nanoknife, because surgery normally is done using a knife, and this is using nanosecond pulses.
No, it is not nanosecond pulses. I just told it's neither nano nor a knife. They use 100 microsecond pulses. They called it nano because they thought people don't know what is nano, what is knife,
No, it's doing in place of a knife, so it's all right.
Knife is all right. Why nano? So they don't know how to count, doctors, they only know how to count money, everything else they don't know how to count.
That's okay.
I am strongly against the doctors who are for money, So here is a lot of publications, if you like, nano knife ablation doubles survival in pancreatic cancer. I don't know how much of you appreciate this because pancreatic 3 to 6 months. In this case they give 10 to 22 months. 10 months means your son can graduate, your daughter can have a baby or get married. You can have a new life, a whole life in 10 months. So that is lot of time for the pancreatic patients, if not for you and I, So I want you to appreciate that, because you will think what big deal 10 months. They go for 2 months extension, breast cancer patient, by paying $100,000 pill, because in 2 months who knows, you might survive, you might get some miracle happen, maybe you will see your daughter graduating, maybe the child is born, you see your grandchildren die, those are all human, fickle mind, it wants everything. So all this is a lot of details, he will tell what is the gap between the things, and so it is safe and effective alternative to conventional ablation, because in the case of normally they use heat and radio frequency ablation, there the protein, nearby surrounding protein will be denatured because they do not distinguish. Here we told the field is confined in the region of the needles, so the disturbance or effective affecting the neighbor normal cells is very, very less, And then he says if you do 5 cases, that is his experience, you become proficient, then you can do a better job, even the doctors have to learn. And then This is the maker of the nano knife system. Again, as I told, it does not have nothing to nano. Okay, knife maybe it is. Some you have someone to defend for that. Okay, so use a computer controlled pulse generator, delivers 90 pulses of 3000 volt intensity. Okay, so the field is 1500 volts per centimeter. So what is the electrode? What is the electrode gap?
I have a hunch here. Okay.
Wait, let them answer. What is the electrode gap? Field is 1500 volts per centimeter, the voltage is 3000.
2 centimeters.
Very good. Okay, carry on.
So the hunch is like this. Although you are talking about pulse duration is in microseconds here, I believe that you can go to a higher magnitude of shorter duration too. Okay, it essentially involves generating those pulses, and as when we learn about pulse generation tomorrow, you will see the load alters the pulse shape. That's a very, very important thing which you should understand in these kind of pulse generation techniques. Load is a very important thing. Quite often you ask a builder to generate, get a pulsar of this kind without telling the possible impedance variation of the load, it is incorrect, because it's not like your battery, you just say that this is going to give this voltage. So maybe in that context, probably they started thinking in terms of nanosecond pulses and probably arrived at the optimal level of microsecond. That's how the nano was doing there.
I beg to differ anyways. Okay, by the way, because we started with nano, there are nanosecond electroporation. You use like 10 kV per centimeter to 300 kV per centimeter, okay? And then the nano pulses will be like 10 nanosecond to 300 nanosecond, okay? Higher 300 volts per centimeter, 300 kV per centimeter means 10 nanosecond, okay? 10 kV per centimeter means 60 nanosecond, 300 nanosecond like that. No human is being treated yet, so I am not for nanosecond pulses. They call nano because they thought people are fools, people like me won't know the difference like that. They do not know that I know the difference between nano and micro. Okay, they just call, people put the name, correct, smart thing like that. How can a phone be smart? Smartphone you call. How can an inanimate object be smart or effective or anything? It is what we put in, okay. So people call it names, okay, we do not have to justify why they call it that way. Okay, that is my take, okay. So nanosecond pulse electroporation is there is one group, they got millions of grants, they do it, but it will not take soon, it will take another 20, 30, maybe never. Which doctor has the guts to use 300 kV per centimeter application? They will run away, they are already shying away from using electroporation 1200 volts per centimeter, and again it does not make sense to put that much high voltage, and as you said, depending upon the pot, the nano pulse shape will vary. With the rise time and the fall time, already the nanosecond pulse is 10 nanosecond, even 300 nanosecond, your rise time will be some, fall time will be. It will be extremely costly and extremely difficult to make it. So, so I do not understand why you have to go for something when there is something already working effective. Let us first, you should all read the book called Better, because there are many things existing now which can be made better instead of going for new things. I am not against new things, we can parallelly improve existing things and then parallelly do it, okay. Like now just going for new things without improving the system, like going for cashless without putting enough banks, without the bank employees treating the customers correctly, it is not going to happen. You can cry all you want, it will not happen. You have to have the infrastructure first there. It has to be accessible and affordable and doable by someone, okay. Doctors already they are scared of this one. Very few doctors they take the step because they care for patients, okay, or they want to be pioneers, or both. I do not question their intention as long as they help the patient. Patients come first. Make sense? Do you understand? So see, it is 1.5 to 2.3 centimeter probe spacing, so they can adjust it, okay. So typically they use 1500 volts per centimeter if you read, 19 gauge diameter, okay. So yesterday we used what is called 24 gauge. So 19 gauge will be thicker or thinner?
Thicker.
Okay, so they use that kind of wires, okay. So
American gauge?
I think it's, isn't it the same everywhere?
No.
Okay, this is American gauge.
It's no idea.
Yes, it is so. There's different. See, when you read a book, you see, you read some basic books, they do mention, there are some of the authors these days they mention the American gauge, standard wide gauge. Standard wide gauge is the universal, whereas American wide gauge is American gauge.
Okay, these are all American, please. I know normally we say American wire gauge. I assumed it is gauge means
yeah,
American way. No, I'm glad you explained that. I don't. Okay, all it tells you, you use a wire of some thicker.
Yeah, see, because what happens is earlier the books were regional. Okay, so American books would call wire gauge for their own gauge they would use. British books would, or Indian books would use standard wire gauge. But then now the books are going around, the same books are used everywhere. So even American books are talking about in miles as well as kilometers.
Okay, so again, okay, it is delivered using either percutaneously, but in the case of pancreas, you need a theater, okay, operation room, okay, and use laparotomy or laparoscopy. So you don't widely open it, but I will show that. Also, they perform with CT guidance, okay, ultrasound wave, ultrasound based CT guidance, and then you see delivery of the pulses is synchronized to the patient's ECG, which is incorporated in the nano knife pulse generator. Okay, do you know how much this generator cost? Okay, the one I showed you, which I used, $10,000. Okay, it is called BTX CCM. Do you know how much this fellow cost? The nano knife? Just make a guess in dollars. It's not million, close to that. Very costly. Okay.
What is the expense there actually? It's people like you who are expensive, not the equipment per se.
Yeah, you know how cheap to make a pulsar, but they spend.
Expensive people, you don't realize that.
Not only that, it took 10 years, 10 to 15 years, and maybe thousands of engineers to realize this.
Doesn't it feel good to know that you are very expensive?
So it takes time to develop this. To get permission itself takes 3, 4, 5 years. Okay.
Nano knife pulse generator means needles only.
Yeah.
Needles.
Yeah.
They are calling it as
Yeah. Okay, so it is delivered 50 millisecond after the R wave. Everyone remembers PQRST? To prevent generation of arrhythmias. Arrhythmia is irregular heartbeat. So patient must have a pulse rate of under 115. See, this is also, so you have an exclusion criteria. If your pulse rate is not good, you can die. Whereas ECT, we don't put any of that restriction. Some people put it. That's why that Tamanna case is a very good example. She had 2 bypass surgery. She had a hyperthyroid. She is having her left breast removed, and we did ECT for the left side. That's another reason many doctors wouldn't touch her, because she had 2 surgeries, so it's left side. Okay. So if at all we get breast cancer, maybe we should pray we get the right side breast cancer. Okay. See how many issues we have, all because of human nature, correct? So advantages I don't have to tell, we talked about many times, non-thermal, so it is protein denaturation, everything avoided, okay. So here he shows this is Dr. Robert Martin, okay. See, he opens and then how he pulses, okay. So they study using the images and then they decide, where to go in, how to pulse. So here are the 4 steps: transgastric operative approach, ultrasound imaging, axial image of locally advanced pancreatic cancer with the complete superior mesenteric vein occlusion, and then 3-dimensional tumor size imaging, crucial to appropriate the needle placement. See, if it is breast cancer, we can see and put it, head and neck or melanoma, we can put it. Pancreas, it is laparoscopy, you cannot open full, maybe some people open full, still the depth is we do not know how deep the tumor is, correct. So for that to know, they use CT scan and 3D model and then they place it. So it takes a few hours to do this surgery, okay, compared to few minutes using ECT. Make sense? So here again, step 1, step 2, he gives all the details. I will leave that for your reading pleasure, okay.
Look at it another way. You built a small crude ECG equipment more of effort it takes. The same way, when you have a small lesion, you treat that it is accessible, it is going to be shorter, and what is not accessible, depth not known, it will take longer.
Yeah. Very good. So again, more details. I'll skip this also. So conclusions, you can conclude. I told you a lot of points. Okay, I have to go to the gene therapy, so I will skip this also.
There go to the
Close this.
yeah, close that. Just a moment.
Questions until we open this. Does anyone really appreciate, understand the technique? You will use it? Everyone go to medical school, get your medical degree and follow this. I am little older for that. Actually, you won't believe, in 2005 I was in Chicago.
I want to share a story here. We have a professor who is the lifetime professor of the Government of India. He is with the School of Medical Science. Professor Sujay Basu, what's his name?
I will do, you go talk.
He is incidentally alumnus of electrical department at Kharagpur, and as a faculty member with a PhD at IIT Delhi, he registered for MBBS at AIMS, and he got the, his name is Guha, okay, so he registered with AIMS. Government of India gave the permission at that time because, and he used to attend the classes during the day, and he would teach during the night because his salary was coming only after teaching. So he would teach in the night, and he is the one who set up the first biomedical center for excellence at IIT Delhi and AIMS. He is a national professor right now residing on our campus. Okay, but he says it's all good to learn, but he says it's much more good to work in a team.
So what's the point?
What's the point? Yes, you can go, but it is advisable to interact and work with the physicians.
Sir, I had read in a newspaper that IIT Kharagpur is going to start medical program.
Yeah, we are starting MBBS next year.
So they will admit people like me?
Of course.
Make exceptions, yeah. You have to, age shouldn't be a criteria. Indian government has some wonderful criteria. You should be 35. So what if I am 35 years, 2 months old? Age is not age is just a number.
1 billion and very little resources, that's important.
Then make the resources, build the resources, don't stop me. Okay. If you're that is the way. That is the way.
Is less, it has to be cut to the size.
Cut to the size means then put the entrance test, whoever gets the first 100 give, don't go by age, gender, caste, this and all is nonsense. That is over 18th century. Sorry, I am in, don't record all this, edit it please. I am not afraid, we have a host professor, I don't want to put him in school because I will be flying, they cannot catch me. Okay. So I think if you know electrochemotherapy, electrogene therapy is nothing. All we are doing is change the pulses, okay, from again trial and error, no science, no math, okay, no, it's an art still. Okay, they figured out, genes will be different from the chemotherapy molecules. So especially Dr. David Dean, that is where I spent 8 months in 2005, my sabbatical, Northwestern Medical School in the critical care facility. He only did that, I told that cutting the throat and all that. Yeah, at that time I thought, oh God, I need a doctor to do this, correct? I thought, why should I be begging these fellows? I should do that. There I can do it. MD, PhD, they even pay the scholarship. So I was very strongly thinking. Then maybe I became lazy, I guess. I had to leave my job. Sell my home, go and study. You never know what happens. So I thought, okay, I will go and convince some doctors and do this. Rather than me becoming a doctor.
10 minutes, huh?
Very good. Okay, yeah, I will finish in 1 minute. Okay. So this is safe and efficient gene therapy using electrical. Okay, we even studied using laser pulses. Okay, I got a 1-year fellowship to do this into living cells. Everything we are talking into living cells, of course. We have to say because sometimes people will think we are working on dead cells. Okay, we are not going to do that. Okay. Remember, as the medical field moves from treatment of diseases, okay, with genes, then drugs, we need safe and efficient gene delivery systems. Okay. So, we want a non-viral. Remember, viruses are made by nature, they by their inherent nature, they can easily go into your body, we get so many diseases thanks to viruses and bacteria. They can easily go. So, what they do, viral technique is they attach the gene to the virus, okay, they remove the whatever the bad parts and then they inject into the body. So, they will go and sit, you put the receptor, so that it will go and attach to wherever you want it to be. The problem with this is scaling up. You cannot have too many viruses to inject. Second thing, these viruses, though we remove the bad components, remember, they will, survival is the fittest. They will retune themselves, okay, become resistant to that, and they can do anything. That is how the 2 deaths happen, one in France, one in US. They completely banned clinical trials. Okay. So, we want non-viral, again our electrochemotherapy is a non-viral technique, okay, because we are not using any virus to that. Okay. So, non-viral efficient gene transfer technique. Okay. We can use electrical pulses, we can use laser pulses, we can use ultrasound, okay, we can use even LEDs, okay, which emit radiation. So, we can do that. The beauty of this is controllable. Virus, until you inject, you have control. Inside, it can reorient itself, it can grow itself, it can do anything, we do not have any control. Reproducible again, okay, and then repeatable. What is the difference between reproducible and repeatable? When do we say reproduce, when do we say repeat? There is a difference there. Efficient non-viral alternative to poor chemical and viral methods. Okay. So, that is the goal, that we need a chemical, non-chemical, non-viral technique, that is where, okay, we know all this.
See, she asked a question, repeatability and reproducibility. What is it? Reproducibility in general, it could be a different location also. Okay, repeatability essentially means you do it again in the same place. Am I right?
Yeah. Okay, you repeat, it is reproduced in my lab, you repeat in your lab, it is reproduced in my lab. Okay, that is how they do every technique. It will be done in at least minimum 5 to 10 labs. Everybody should get similar results, not exactly, because human, the biological system, they are so variant. It is not like have the resistance with plus minus 2% tolerance and repeat it. No. Okay, there will be, if you see that the statistical way, the error bar will be in this all, okay, they put, because you have to do minimum at least 3 times the experiment, you have to give the average with a standard deviation, because average has no meaning, whoever invented it. Okay. See, the class gets, one person get 10 marks, another person get 90 marks, the average is 50. It neither reflects the 10 points, nor reflects the 90 marks. So, average is a very useless thing which everybody uses it. Okay. I do not use average in my class, I have 90 and above A, 80 to 89 B. If no one gets 90, no one gets A, that is it. I do not do curving, I do not do averaging, I do not do anything, because I did in the beginning, it is 20 years since I am teaching. People ask, what is the average of the class? How does it matter? You are going to get based on your grade what it is. Okay. Average has no meaning. Do you understand what I am talking? Yes. So, at least not in my class, not in my course. If you want to follow, you be my guest. Okay. I won't do that. Okay. So, yeah.
There is a sharing which says statistics can be shown to prove your point. That is why average has no meaning.
Oh, that is another thing. George Bernard Shaw, how many of you know? He is a great person. I did it in my second year when I was taking the statistics course, engineering, Salem and GCE, Salem. Okay. There are 3 kinds of lies, damn lies, statistics. That is what it is. Okay. But we are using it very seriously.
Unfortunately, medical profession uses it maximum.
Exactly. Remember, they test it on 2000 people and 7 billion people use it. That is how it is, because they have no choice, this is what it is, best among the worst. Okay.
Doctors keep doing their experiment on patient
Oh yeah, one by one, yeah, we are all guinea pigs for them, okay. So what is the advantage? It's very effective and delivered to the tissue correctly, so that is the issue. Then you can avoid drug side effect, it fixes the problem at the source. Do you know what is gene therapy means? If there is a faulty gene, either we can repair it or remove it and put a new gene. So when the cells divide, you keep dividing, you get it, the whole thing can be fixed. So there is no treatment there, it is refixing your whole body. So it is really good if it is done properly and if it is working properly, okay. So I want you to appreciate that one, okay. And it fixes the problem at the source, that is what it is, okay. Can eliminate and prevent hereditary diseases, that is what when you are the lady is pregnant, you can see some genes are not correct, then we can go and fix it, okay. That is the goal, it is not yet done though. Holds the potential to provide patient friendly treatment regimens for a variety of diseases, okay. Advantages: hard to deliver genes efficiently throughout a system or tissue, but we do not need, all you need is 1 or 2 cells take up the genes, you are done, okay, they can reproduce it. Okay. It is quite expensive if you do not use electrical or laser pulses, okay. The long term effects of gene therapy are unknown, okay, because it is a baby, it is still growing field, okay. So maybe I will skip all this, okay. Advantage of non-viral, which is our electro gene therapy, safer, cell independent, okay, that is another thing. Virus you have to put whichever is the dependent on the cells and then the molecules, okay. No limitation of the size of the genes delivered, because we can apply more voltage, we can open up bigger pores, okay, we do not have all those things. Okay. So, the viral vectors disadvantages: safety, scaling up, cell dependent, long term effects. Okay. So, here disadvantages: low levels of gene transfer, but as I said that is good enough still, relatively inefficient as of today. Okay. So, if you do more work, okay, they can use electrical pulses, opto use laser pulses, sono is ultrasound, liposuction is you can go directly and inject into the tissue. Okay. These are the various things. These are the various advantages of electro gene therapy, same as ECT, you do not have to go twice. Okay. Again it is the same concept. Okay. DNA, okay, here in no drag molecule, you take the DNA molecule or plasmid, okay, and then you inject needle, okay, and then the gene will go and then it will go and it will multiply. Okay. The pulse parameters yesterday I wrote, who remembers gene therapy? Volts per meter, you have to be very careful with the units. Very good. Yes, this is what it is, okay. So, we did it in Northwestern Medical School, acute lung disease, okay, lot of people die out of this, especially youngsters, so he got lot of money for this. You see here it is called this is a plate electrode, this one we call slightly different, it will be like like a concave one, okay. So, we put across the chest of the thing. So, basically you cut a slit. You should see these doctors, 3 of them, one is from Venezuela, one is from Poland, one is from Middle East. God, it will be like an art, how you draw using a pencil sketch, they will do. It was so fantastic, I was in the same room as the 4 of us had the best time of our life, at least I had. So, you cut a slit, there will not be many times a drop of blood, so nicely they will cut and then you inject the gene into it, okay, and then you apply the pulse across the chest, because we want the lung to get it, so we apply across the chest and then we open up and see, okay, you will see that, you see this was unpulsed lung, this is the pulsed lung, you see the gene is how uniformly it is spread, I do not know, can you see that? Do I switch off the light? See here you can see in the screen nicely. Yeah, see in the television screen, they are much better than here. So, what happens? Why they do not go to this line? Okay, you see here this is a non-pulsed virgin we call a control lung, this is the rat, okay, and then this one, you see how nicely it splits. So we cut it and take it, and I think I told you the story, we took it to the pathology, they said no change, we are happy, he was wondering. Okay. So here it shows how it depends upon the drug dosage, so the DNA dosage. Okay. No DNA, 100 microgram, we use very small quantity, 200 microgram, 600 microgram. Okay. Here is the luciferase expression, meaning how much the DNA is taken. So we can see that increasing the dosage you have more expression, means more gene will be going inside it. Here again depends on the pulse time, okay, millisecond. They tried with no pulse, then 0.01 meaning 100 microsecond, no, then 0.5 millisecond, 10 millisecond. So that is why he uses 10 millisecond, 200 volts per centimeter, 1 pulse per second, because he still uses the normal normal machine, and then the DNA dosage varies. Okay. So again, where lots of time course of gene expression, okay, with respect to time it varies, how the voltage, okay. So all this, you study each parameter keeping everything else constant, and then you come up with a set of pulse parameters. Okay. Again here in the mouse lung, how it is distributed uniformly, this is what, okay, this is the pathology case, okay, A, B, C, D is, then this fellow is naive, means no treatment, gene only, EP, electrical pulse only, EP plus gene, okay, electrical pulse plus gene. Okay. So both, so this is how we do control, no treatment, drug only or gene only, then pulse only, then pulse plus the gene, so that we get all the cases. So this tells you, do you see any difference? Very less difference. Okay. So pathologically not much difference, but however this rat will be cured of that lung disease, not the others. Okay. So some cases we use electrical pulse only, it gives similar values or sometimes better values. Okay. So again this is the inflammation. Okay. If you have less inflammation, you are better, correct. So the luciferase will tell you how much it went inside. Okay. IL-6 is the protein, again released because of this. We study after 1 or 2 hours and then after 24 hours. Okay. So that whether you have vascular conjunction, okay, there is conjunction here, whereas in all these no. Okay. So that means the treatment is effective. Again more studies, I will skip all this. This is, okay, 1 second. Okay, this is what, remember ex vivo, we cut that mesenteric vessel of that rat. I did this experiment and then I killed that rat and then studied all that. Okay. You put this vessel here, okay, this is called that spoon electrode. Okay. You will have that electrolyte here, dip it into this. Okay. These are the electrodes, apply the electrical pulses, and then you study the expression, and then we did the electric field study. Okay. We have the paper on this. Okay, I will skip all this. Okay, it does not have a, okay, we can use laser pulses also. We use nanosecond laser pulses, okay, very small intensity but lot of pulses. Okay, that I did it at Purdue. Okay, with this I close. Thank you.
We have a break now. This is what it is. Okay. So the two aspects we have talked about here, as again remembering Lord Kelvin, I will not put the whole quote, but you need to have, in a very simple way, he says, hang numbers. You have to give a number. I say Raju is there, I have to say he is 50 kgs and 5 feet 6 inches tall, then it gets completely specified. Otherwise, he is not, it is not complete. So similarly, whenever I talk about an electrical device, it becomes, we I and P. These are the three things which become very, very important. In fact, if you want to consider the, I will rather say S than P, it accommodates the fact that there are reactive elements too. Now, therefore, you have one aspect is measurement. Measurement gives you some indices so that you can control. Now, this is where today the most instruments are digital and they are controlled by ICT, the information communication technology, and we tend to use the word smart. Agreed, no device is smarter than us, we are the smartest, okay? And but nevertheless, our endeavor has always been to imitate the nature. It's a poor imitation. We are all the time trying to imitate and better, okay? There is a book which long time ago when I was a student, I had a friend who gave it to one of our friends who was feeling that life is not worth, okay, born to win. According to this book, everybody is born with a purpose to win. So, smartness is getting built, and in fact, the other area where I am interested, power and energy systems, people are coming up with what we call smart grid. One of the things, the person who gave a talk here first time, we debated, and what we said is grid is getting smarter. Though it's called smart grid, it's getting smarter by the day. Tomorrow I have to give a talk somewhere else on clean energy issues. So I was going through some documents this morning. There is an amendment to the Electricity Act 2014 amendment, it's in the Parliament at the moment, which will become the Electricity Act 2014, which is involving use of smart infrastructure for operating the system. So this is one aspect of it. Other aspect of it is therapeutic. Spelling may be wrong. Okay, spelling is wrong. Please correct it. So therapeutic, and then this is where the high voltage comes in picture. Now, high voltage is a loose word which corresponds to high field. When you talk of the fields, you have two ways to look at. One, with respect to time, you have a constant thing which we call DC. Alternatively, a slowly varying stuff, a slowly varying signal, but alternating and periodic. These are termed as somewhat static fields. Apart from this, you have impulses. Impulses, by definition, if you go back to the circuit theory, it says it's an excitation which tends to become very large and lasts for very small or infinitesimal duration. So, but in practice, systems are physical. You can't suddenly change your state. Every system has inertia. You get up from the, you say morning you open your eyes. Do you immediately get up from the bed? No. You take a little time. You even wonder where you are to begin with. Okay?
Do you?
No. Everybody does that. Okay. Maybe one does for an hour, one does for a minute, one does for half a minute, but precisely they do it, there is a finite time. And often for the purposes of evaluation in the lab, we take them as double exponentials. Okay? And these are called as impulses. There is a difference between a transient and an impulse. Transient physically gets generated, whereas impulse is an intentional generation in the laboratory or in the circuit. Maybe mathematically, maybe physically, this is the thing. So, what it means, you end up having electric fields. Now, here we are looking at using high voltage for here, and today's topic is only to look at that. So, it basically amounts to having, let us say this is a body organ, alright. You have two electrodes. I will initially take a point plane, that may not be the ultimate thing, but I will consider an initial electrode setup to be a point plane. So, what do you have? You have a organ which has its own epsilon r, mu r or sigma r. So, this is, so it has its properties you need to find. So, you have a complex geometry, you have the excitation given here, and you are trying to see how it works. Okay? That is the basic thing. So, what do we have? We look at that whole process of doing this involves having electrostatic fields which are basically governed by so I will walk you through few fundamentals of electrostatics, which will perhaps you have done maybe in the school physics, maybe at the undergraduate level, and if you are a communication engineer, you might have done even at the graduate level. But knowing the kind of, so you need certain basic principles that are used in the study, which we come across very often, and what this slide shows is basically two things. Calculus has been a wonderful tool for engineers. There are two things we calculate in any system: rate of change of a quantity, the other is the net energy input in a system. One is a differential, other is an integral. Now, when you have a distributed nature of the system, you may have over a surface, over a volume. So, depending on that, over a line. Okay.
Excuse me, I want to take a diversion here. Everybody knows who invented calculus? Newton. You know how he came across that? Remember, he saw the apple falling, then he came up with the gravity, then he wondered whether the apple falls with the same speed everywhere. That's when dv over dx came. Okay? It's fantastic. It's called Newton's dot moments. That's when they talk about Newton's invention of lighting and discovery of lighting and everything. Right? It should be Newton's light moments. Anyway, watch that video. PBS video. It's fantastic. That's where I learned. People think calculus means something, abstract. No, it's real. Newton's dot moments.
So, actually we take it for granted today. The calculus has been with us so long that we take it for granted, and only when you deal with engineers who have been on field for a long time, you realize how soon we forget calculus. One. The other is when you deal with policy makers you deal with regulators, you deal with the lawyers, because today electricity is also a commodity. So, you don't no longer deal it like Ohm's law governs 10%, rest of it is others. Okay. So, you need path integral, you need surface integral. So, like my friends earlier days they would say you are a line. Okay. So, my colleague is there, he would always make fun of me saying you look like a line, do not become a dot. So, that is the now, but these are the basic equations, if you remember correctly, these are the two basic equations which govern the entire process. So, this is basically the we are of course in trying to do these applications we do not really need this. Electromagnetics is very vast, and in fact 4 equations is what makes the electrical engineering, okay, or electrical science. It is more fundamental in fact. If you are able to appreciate every electrical engineering problem from an electromagnetic perspective, you are stronger in understanding that. Okay. So, now this gives rise to what do you really mean by a field? Field means supposing you have a certain phenomena, it has a certain force, it has an orientation, that is what we call field. The presence is felt. Okay. So, you have both a magnitude as well as a direction for that, and that is the reason why we call them vectors. Now, here incidentally when we are dealing with some alternating and periodic, we tend to deal with, for the sake of convenience, with phases. Please remember one thing, when dealing with phases you must have signal of only one frequency at a time, otherwise a phasor is as good as a vector, but for the fact a vector, every phasor is a vector, but every vector is not a phasor. This has to be, and how do you get? You get the direction by taking a tangent at that point, and there are always two field lines will never cross. Another thing, as we define potential, we will see that we can always, let us say I take two parallel planes and I apply a potential across the two, then I can say my the field lines are going to be oriented this way. Let me put a positive polarity here, so I can. What we see, yes, some of you may have recognized immediately and said, what about fringing? At the moment, let us take an ideal scenario. Okay. So, if I say that this is plus V and this is 0, I have lines corresponding to some voltage V1, V2, V3 here. These are called equipots or equipotentials. So, generally these equipotentials are orthogonal to the electric field lines. Now, the number of lines is also a index of what we call the field strength there. Okay. So, now coming to the charge, the basic fundamental charge is electron, this is given by this, and you basically use, and how one can get the this is basic idea of how you get gamma rays and the photonic energy and other things. Now, you notice this is the quantified unit of one charge, and we have decided to have one unit of charge as coulomb, which is almost 1.6 in 10 power minus 19, such a small quantity, right. Now, if you look at the force between two charges, what you have here is charges which are like in nature, unlike in nature. So, you have what we call a force of repulsion or force of attraction, and out here what we are considering is point charges. Now, let me have number of point charges placed adjacent to each other. What do we have? We have a line charge. Imagine a transmission line conductor or a telephone conductor at a particular instant of time excited by a particular voltage. Telephone, there is no issue, it is a DC. So, whatever be the time, it is, if you take power line, you do have DC lines these days, and the future is that you are going to have both DC grids as well as AC grids. AC grids for the integrated large networks and DC grids for the small buildings and small sector. So, DC is, so both Edison and who else, Tesla, both of them will work together. There was a war at one time, but they are going to be together now. So, this is the basic fundamental law which gives, and I want you to observe one thing. This is what we call inverse square law of electrostatics. Every phenomena has inverse square law, no matter what that is. Every single phenomena has the inverse square law, and this is the most fundamental way of defining it. Okay. Take the next. This is of course all of you know, and this is a simple application trying to find the force, and this is a small example which you can see the units, all the values are given, you can calculate the force, and it shows in terms of the vectors. You know I, j, k, I do not need to say that, they are the unit vectors in x, y, z directions, I along x, j along y and k along the z direction. Now, this is a two dimensional thing, so you have only I and j here. Is that okay? Now, supposing you have large number of charges, what do? See, we are slowly moving. We had a deterministic inverse square law equation. Okay. When you had two discrete charges, it was just an equation. Now, when you move from there to 3 point charges, you are having to get forces due to interaction between these two and these two to get the total force on this. So, you got a summation. Now, imagine if you have, instead of having discrete charges, you have uniformly distributed surface of charges. When you need to get complete effect of that, what will happen? This summation will be by taking all such small elements, which will give rise to what you call integration. You see the immediate application of the integration in the whole process. And one other very important point I want you to observe is conservation of energy and mass is fundamental to all analysis we do in any field of science and engineering. In fact, when I said finite element method, it is in fact you try to conserve the energy in that element and determine the conditions. So, it is the same. Now, you try to find the effect of this force field, we define that as the electric field intensity. In fact, it is intensity is missing here, that should be the, and what you find here the brackets is some analogous quantity taken from the gravitational field for Newtonian mechanics. Now, you might, this is taken from the open courseware of MIT physics course. Okay. There is some of these, in fact. So, what do? You define a unit charge and you find the force on that you define as the, which has a orientation as well as a magnitude. It is a vector, right. So, when you have such number of them, you superpose them, and it does not take long for us to realize that this summation itself becomes integration. That is what you see. You remember numerical integration, you had Simpson's 1/3 rule, then Runge-Kutta 4th order, 5th order, right. So, all that basically is you are taking a smaller region, you are trying to discretize that. So, this is how the field lines look. This is a very important aspect. You have this is the like poles or like charges, you can see the repulsion, and unlike charges. So, this I have already mentioned that the field line has a direction depending on the tangent at the field at that point, and they move away from positive charges. See, we have defined this way. Well, you know, that is how we have defined the current also, to be positive from plus to minus. But soon we realize that it is the electrons that are determining the current, and they do not, they flow in the other way around. So, convention is one, actual thing is another. Am I right? So, the other very important aspect is, I said this therapeutic nature of electrical engineering is application of high voltages, which essentially is static in nature. Now, most electrostatic applications need three things: charging, acceleration, and collection. Some way the charge, or I will call it as movement of the charges. What you say as current is nothing but a movement of the charges. How do you create these? There are three basic ways. One is a triboelectric or friction, when you rub. All of you have at least seen women who have long hair in winter, when they try to comb, there is a force of attraction or repulsion taking place.
When you open the
Door and no that's, and the other thing is some of these shirts are there, synthetic shirts, they cling to your body when you, okay. Then contact, this it's said as transfer here, I call it contact. You have a charged body connected to the other one. So, this is by triboelectric effect, friction, this is contact, other is induction. So, so what happens? Let us see, how do we learn? We learn by reading, we learn by listening, we learn by doing. So, there are three different things. You can associate reading as some sort of a, say, friction, this thing, induction, and listening could be transfer, and other thing could be, by doing could be friction, okay. That is the way you can remember. Now, some other things, like even in the morning we were discussing about the origin of nano knife. I am trying to give a reason, not for justifying that, more for how I can easily know that this means this. These are mnemonics. Computer science calls it mnemonics. You have ways of trying to recall things without effort on your memory, okay. There should be no load on your head, that is very important. Now, there is a very important configuration of charges which we call dipoles, which is a combination of two equal and opposite charges, and often this product, which we call dipole moment, becomes very important in this particular case. It does not take long to realize that the field intensity at any point, obviously this distance is small compared to the distance to the point, it turns out to be inversely proportional to Q. It is a very interesting result. I take a course on illumination for architecture students. I find that optics also has similar laws, and it is very useful in placing the lamps in an environment, and you have two normal sources of light. One is a point source, other is a line source, and you will quickly realize when you move from point to line, the field intensity changes from inverse square to inverse distance. What was 1 over r squared becomes 1 over r. Similarly, the light intensity on a work plane changes from inverse square to inverse distance, and you will be amazed at knowing that if you have a plane of charge, the electric field intensity is independent of the distance. Similarly, when I have a plane sheet of light, the intensity is going to be uniform, independent of the depth where I mount it. That is why you will see in most boardrooms over the work table, the way the lamps are made with a diffuser that forms a plane source. So, the height does not matter. Otherwise, you see long rods protruding and creating trouble. Sometimes they fall on somebody's work table, cause accidents. So, now you have the dipoles. Observe how you can bring it down to a sort of a point. This is a finite dipole, this is a point dipole. Okay. So, when does that happen? When r is very large compared to A. Now, I was all the time telling you how the summation moves to integral. That is what is the take home from this slide. You have the distributed charges, you take small elements. You see again very interesting thing, you will be modeling this part, this is the right point where I should say, whenever you have a large volume or a surface, you have to take elements. The best element in a line is a dot, okay. In a plane is a square, and in a volume is a cube. First remember this, then you remember that the two things which you will be more often concerned is R and C, because we think most of the times we are looking at the field phenomena where it is electric. So, you can think in terms of if it is a small path, you can have a small segment. So, you can go by this rho L by A, and a small disc can be taken as an elemental electrode, you get epsilon A by D, where D is the thickness. So, these are useful relations which together with the integral calculus help you to take care of the entire phenomena. Now, why do you need all this? I mean, you might be wondering, there is so much of software and everything can be done, still I am going through this. How do you know that the software is giving you the correct thing? You give a regular geometry problem to that, find it out, it gives you expected results which can be correlated with the macroscopic measurements which are VIS. Macroscopic measurements are only in VIS. You do not measure charge on as charge itself. Okay. So, this is what I was trying to. So, you see how we get the electric field due to a charge distribution which becomes an integral. Okay. Now, this is a volume charge, a similar thing has been done, line charge, area charge. So, this I can skip, I have already given this idea, there is a picture is to complete what I have said. Now, this is a line charge, this is how it is. Now, why I have given this is, this I have already shared this PPT with you, there is a link, it has got a nice multimedia animation which you should, Of course, there is a personal response system which it talks about, that is not for us, but that is for the students who register for the course there. Okay. Like you have in India, that we have now started using what is called Moodle. Through Moodle we have personal response systems. In fact, I do that through email with my students all the time, whatever that needs to be done. So, this is a ring of charge. Ring of charge is essentially a finite line charge, if you see carefully, and it is a very useful phenomenon. Electrical engineers are very conversant, because there are only two laws to govern your generator and motor, right hand rule and the left hand rule, and you always open the rotor or the armature out and then work on that. Okay. So, a ring of charge, how it is, and this is the, what do you do whenever you are given a problem? Identify the symmetry that is there, you define the variables of interest, then write the equations, then you can start working, because there is a calculus is involved. So, you may have to get the limits and the equations in the simple way to be able to analyze, and then you integrate for a very, and you get the solution. So, this is how you get that. So, do you see this? For a dipole, it falls as 1 over r cubed, for a point charge 1 over r squared, for a line charge 1 over r. It is a very useful result. Okay. And mind you, we can get everything from this. Coulomb's law tells us only this, and a point is a smallest entity as far as this goes. Number of points becomes a line, number of lines summed together will become a volume, a surface, and those surfaces put together becomes volume. So, it all goes. So, I want you to see from a holistic point of view. Never ever think that I am electrical, you are electronic, he is mechanical, he is chemical. No, we are all physicists. Okay. So, this is the way it goes. Now, from there we were talking about this potential also earlier also. So, we said, yeah, this is a very important conclusion which you have. All the forces are conservative. Here of course, only gravity and electrostatics have been compared. So, you find them, and from there you can define. Now, actually there is nothing called as absolute potential. Potential is always with respect to something. You have to choose a reference, and therefore, the two equations which are very important, one is the potential difference, other is the energy differential. So, what that first one gives you the potential difference, which is by definition an integration of the field intensity change which takes place over that, okay, while work done is the work in addition to maintain that potential difference. So, this is how we get potential and energy. Now, this is the, so young people, one very interesting question I often come across when I sit on the committees is dimensional formula of volt, dimensional formula of ampere, dimensional formula will be what? Think about it. Okay. Go back, look at SI units. Okay. There are few fundamental units. We all know length, mass and time. Something more is there. Okay. So, that will complete your, and a very good pet, one of my good friends, he always has a habit, and I find the higher we go in our education, more difficult it is becoming to answer this question. So, what do we have? Charges are there, they create potentials. So, you look at the change in potential. which is related to your electric field. Therefore, you are getting two things. You need how much energy to be pumped in, how is the field distributed, that decides, and therefore computing the field is a very important thing. If it is simple geometry, you can analytically compute, you can get a quick summary knowing this way, but then for overall thing, complex thing, see here I have drawn a capacitor which is a simple dielectric of one material. But is it so? You take a, let us say, pancreas. Is it of the same uniform biological material all across? No. The conductivity could be varying, resistivity could be varying, permeability could be varying, permittivity could be varying. Obviously, permeability is of not much significance here, for simple reason we are looking at more the electrostatic conduction. So, this is how you end up getting, these are the 3-dimensional plots which show your potential curves and field lines. So, you have, so we always look at what potential difference or additional work that needs to be done. Change. Yesterday we were talking about something. What do? We always take a reference. I will tell you, my blood pressure is normally around 90/60. So, that is my reference. Even if it goes to 70, it is high. That is how my doctor reckons. Okay. Yes, 140/80 is considered to be normal. That is a mean. Remember that over a large population. So, reference becomes a very important thing. So, it is the delta U and delta V. Okay. So, I use analogies from other fields because it helps us to remember things. Now, you look at the point charge, arbitrary path, how do you get the potential? That is what is shown. This is okay. So, this is, so you get potential is, you had field as inverse square while potential is inverse distance. Now, from potential one should be able to get E. So, from E you are getting V by integrating, which means the opposite of that you need to differentiate to get. That is what morning ma'am had given you 1.5 kV per centimeter, and then she gave you the applied voltage. From there you had to get the distance. So, basically simple. There are two inherent assumptions over there. The assumption was it was a uniform field. This is what I call as a uniform field, this I call as a non-uniform field. Now, another very interesting thing, field intensity becomes larger when it is non-uniform. As a test engineer, I need to apply lower voltage to get the same thing. That is a very important point. So, how do we derive E from V?
Also the shape, the needle tip will have higher V.
Yeah, that is because of the radius of curvature. You remember the point charge, you take the example of a sphere, keep increasing the R, the field reduces. Keep reducing the R, field increases. It is a very simple thing. I do not know whether you have seen the high voltage substations and high voltage labs. You will find most of the high voltage terminals are having spherical ends, so that there is no corona, because already these systems are very low current systems. So, if you allow corona to take place, the energy gets depleted in the wrong path. Okay. Do you get my point? There is an intended path, unintended path. So, you have, you must have come across teachers, who do not allow you to ask any question at all, and there are teachers who allow any number of questions. So, what I feel is we need to have a balance. What we do, over the years we get the idea, okay, some questions we allow, from that we get the understanding how the class needs to know, what the class needs to know. Now, so this is a what do? How much energy to put two charges, let us say. So, first charge is free, so you put it, there is no problem, right, and second charge sees the first one, so the effect is there. This is the work done. Who is anybody elder sibling? Eldest sibling in the family? Eldest sibling has nobody to see, okay, learns everything by experiment, whereas the later ones are very quick to learn. They have a elder sibling to train them.
Or to follow, not necessarily train.
Well, either way you
Say
can.
elder sibling, so he wants to brag about it.
No, I am not bragging about it, I am just telling. Okay. Now, let us say we move from 1 to 3. So, you see it is changing much more. It can be n number of charges, and actually you are dealing with fluids in biological systems which are ionic in nature apart from solid mass. It is a very, very crucial thing. In fact, when she was working at IISc, there was one problem which she was working on, was how to model a charged body flying in clouds. Now, normally if you see aircraft goes through the clouds which are ripe in lightning activity, but since they are made of, normal passenger aircrafts are made of a all metal body, so it acts as a Gaussian surface. So, there is no problem. The net voltage even for a very large intense cloud could be around hundreds of volts, but the defense forces tend to have lighter aircrafts for ease of maneuverability. So, they use composites. So, they act as dielectrics and hundreds of kilovolts built up between tip to the tail, nose to tail. So, now there will be potential differences. So, one of the things which we were trying to compute at that time was, supposing I have a field like this, there are two electrodes, in between there is a floating potential body which is also moving. Okay. So, that is how the complexity keeps on increasing. So, this is the electric field and potentials. So, you need to use superposition, you need to use calculus, you need to remember how these material properties vary over the time. So, now supposing you put a charged particle in a field, the force can be given by this, and the work to be done to move a charge over a certain potential difference is given by this. Yeah, I introduced you to Gauss Law. This is considered to be the first of the Maxwell's. In fact, Maxwell integrated everything, and who found all those things? Faraday. Okay, Maxwell gave the explanations. So, you need both. Faraday was unschooled technocrat, okay, but he did a lot of things.
Homeschool.
Okay, fine. Unschooled means, so
Means no study.
this is how the Gauss Law, okay. Time is up, that is why I am going to quickly go through this, and this is basic idea of Gauss Law, and equivalent of this is Ampere's law in electromagnetics, okay. But remember, the magnetic poles cannot exist in isolation, as electric poles can, electric charges cannot. So, this is how one can use this to calculate the electric field under different situations. This is when it is obliquely linking a plane and can be used. Now, this is a surface integral, mind you, please be very clear about it. It is a surface integral, and more, in fact, aircraft surface is forming that. So, this is a open, this is a closed surfaces. So, you take dA, which is normal, you can get, if there is a electric field going outward beyond that, it is 0 and below that 0. Okay. So, this is how you get. Now, there is a possibility that electric field itself is not constant. In that case, you define elemental flux and you have to integrate over the entire surface. So, this is, I will skip this and I will make a stop here. What I will do now, remember one crucial thing which we are doing is applying pulses, which are impulses and repetitive. So, we are going to use ElectNet. So, there is a particular video on ElectNet which I have already shared with you people.
Yes.
We will see that in the afternoon to begin with. Then I will guide you through one example given on their website, but you people come by installing the ElectNet on your PC, laptop, so that we will give you some exercises which you can do it during the. And also I would appreciate that you all tell us anything that you want us to cover, because you are left with 2 more hours of tomorrow morning plus 2 hours in the afternoon tomorrow and 3 hours today afternoon. Today I would like that we meet at 2:30 in the afternoon, not at 2, because we are now all of us are going to go to the School of Medical Science has old location on this Ramanujan complex. That is where they have their seminar rooms. We will go for Sandeep's defense there, which begins in another half an hour. Of course, we both will go to energy school and come there in the meantime. Okay. So, and does anybody know the Vikramshila basement? Okay. So, they will take you. Okay. Raju can come to the energy school and then go with me for the Viva. Okay. So, we will break here. Is that okay?
Everyone come on time, please.
Yeah. We will have questions from Sandeep's defense in the examination.